Now, we talked about getting data into the cloud, but obviously getting data out of the cloud is very expensive. All the cloud vendors are the same, $10 a gigabyte. That can rack up really, really quickly. So if you're trying to maintain coherency between your on-premise and your cloud, you have a lot of challenges there because you want to make sure that what you push down, one, is authorized to be pushed down. You don't want big spice transients going over the wire, right? But you may want your logs and your results files, so you want that controlled. But more importantly, that's, our selective write-back lets you get that level of control. But most importantly, all writes are saved as deltas. So we know what you wrote. If you appended to a file, we'll just send the appended bits back. If you just modified a file somewhere in between, we'll just send those bits back. We do not copy back any data that we read over the wire because we already know what it is. And we know our writes, and we can send those writes back as deltas, so we can keep your costs, under control. However, one of the big challenges is, people worry about attack surfaces. And if you leave complex file systems up in the cloud, I'm not saying they're insecure, it's a large active surface. But if you just use ephemeral caching like we do, when the job is done, the data is gone, it doesn't exist, right? You were never there. And that's the power. So if we look at some of the results we've achieved, this is a workflow, and we're able to just extract just the job that needs to run. And these numbers are fairly typical, just the bits that you need, right? This is your workflow, but I just want that job. I want to extract that dependency, right? You can burst like crazy because the files you're pulling over are a fraction of what's actually there on your trees. And remember, we can do it at the extent basis. So if you only read, as I mentioned earlier, a few bytes of a file, we'll only transfer those bytes, right? We won't transfer the whole file. We have extent-level granularity on individual files as well. And because we're using NVMe caching, we can eliminate those I/O wait states presented by your filers, right? Not only that, we can provide very, very low latency I/O behavior and not variable latency behavior that we see in complex file systems.